a pipeline which was currently being used for transporting gas at 75 bar to transporting carbon dioxide. I'm saying in the gas phase, but you need to, as part of this study, you need to look at the phase diagram for carbon dioxide and challenge that. Okay? Now, the current pipeline design and operation complies with IGTD1 edition 5, and I've given you as one of the documents the design section of TD1. The reason is that because that was the baseline that this change of use was being considered from, but once you're not operating in national gas, you've really, to comply with the legislation in the UK, you've then got to comply with this standard here, which I believe will be available to you through the university library. Right, okay, that's fine. I'm sure that historically TD1 wasn't always available, which is why I've given you the section. Right, okay. So the first thing that we've got to do, the pipeline is already in existence, and we've been told it complies with TD1, and then once its use has been changed, it's got to comply with PD8010 Part 1. And what that means is you've got to go through essentially a design review process. You've got to look at what the TD1 design review would have required, and then you've got to compare that with what the 8010 design requires and decide if you've got compliance. That should be, for most things, that should be fairly straightforward, because both TD1 and PD8010 in the UK, both of those codes allow you to comply with the pipeline safety regulations, so there's no major conflicts between them. What you'll find is that there's more detail in some aspects in one code versus the other. Okay, so what you've got to do is check and compare the material selection and design requirements in both standards. You've got to assess the maximum allowable operating pressure for CO2, right? That means looking at the phase diagram of CO2, looking at the operating conditions that the pipeline will see, and then you've got to decide what the MAOP could be. What you can't do is assume that the MAOP will be 75 bar just simply because that's what it was historically. Then there'll be a number of technical assessments that need to be carried out because you're changing the substance. So you've got to identify what those technical assessments are, and then you've got to identify the activities that will need to be undertaken to change the use of the pipeline. Okay?
Regarding this MOP, is it the same you say?
Sorry?
Is it the same, 78?
No. We'll come on to that when we look at the phase diagram, and I'll explain to you what the issues are, and then you need to think about how you feel it should be dealt with. Right now, in doing this, the key issues are using codes and standards is always tedious, and it's very easy to look at them and say, oh, that applies. What you need to do is have a logical approach which shows that you've looked at all of the requirements of the code and you've taken it through in a logical step. So I think one of the first things you've got to do is sketch out a kind of algorithm or logic diagram which basically says, right, we're starting here, this is what we know, this is what we're going to do, these are the sections of the code we're going to consider. The MAOP of assessing the MAOP, that certainly when we did this project, the real project, that was very tedious. Okay, so you may well find it tedious as well, but you know we'll get through that. There are a number of technical assessments that will need to be done, and you need to consider what those technical assessments will be, and then you have to explain the technical assessments and why they need to be done. You don't have to do them, right? You don't have to do the technical assessments because that would be well, that would not be possible in this sort of assignment, but you need to know or have decided what should be done. All right? And then you need to identify the activities which the operator needs to do to change the use of the pipeline. So you've got to think about the design checks that need to be done. Some of them I will expect you to do as part of this work, because some of the feasibility checks are fairly straightforward for you to do, and I'll expect you to do them, and you'll get marked on the calculations and the accuracy of the calculations. Okay. But there will be a number of things that the operator needs to do to change the use, and essentially if the operator is asking you to do this feasibility study, what they're saying is, first of all, can I do it? And then in order to do it, what do I need to do? Okay? Right, so the code checks that you've got to do, the main ones are the design criteria and the material requirements. You need to look at the construction standards and decide whether the construction standards that TD1 that a TD1 pipeline was built to is going to be acceptable to 8010. Well, I think a quick assessment of the codes, you should be able to come to that conclusion reasonably straightforward. The test requirements. These are the test requirements. The pre-commissioning tests that the pipeline will have already seen. Pre-commissioning tests are important because what they do, depending on the level of the test, they will fail defects which are big enough to fail at the test level. So the higher the test, the more stringent the requirements that have been applied to the pipeline. Then you've got to consider the risk levels. Now,
Before you move on, the test requirement, you mean hydro test, right?
Yeah, yeah. I'm not expecting any risk analysis at all here. The main risks that are controlled in a major accident hazard pipeline, which we discussed at the safety lecture, are the routing of the pipeline and the distance from occupied buildings. Okay, so you're changing you've got to look at the proximity distance that is in place for the pipeline at the moment. It's been transporting natural gas at 75 bar. So you've got to work out that proximity distance, and then you've got, having decided what operating pressure you're going to go for the CO2, you've then got to decide what the proximity distance will be for its use under CO2. And to do that, you're going to have to go to the 8010 code.
Excuse me, but this thing is already there. The pipeline is there already.
Yep.
Can I change the proximity distance again?
No, you can't. You can't change the proximity distance. Well, you can. If you change the fluid in the pipeline, the proximity distance, which essentially defines the risk in the pipeline, automatically changes. Okay. Now, so what you say is, well, you want to do the minimum change to the pipeline. So if the proximity distance is much greater in the change of use, you then might think that means that the risks, it means you may need to think, well, I've got to reduce the pressure to bring the distance in, or I've got to apply protection. You've got to basically just apply design thinking at that point.
Sorry, next question regarding this design criteria, material requirements, and construction standards. For the different codes, we need to compare all of them like one by one.
That would be the best way to do it, but the key, this is why you need to think of a logic approach and an algorithm, because you want the codes. You look at the codes and you'll see that mainly they cover the same issues, but the clause numbers will be different. So you need to think, well, what actually is the most important thing that we need to compare? So, for example, design criteria, the key thing with design is going to be the design factor. And the design factor depends on how you've set the pressure. The pipeline already exists, so you've got the wall thickness, so it already exists, so you know the material. Does the material comply with both codes? That should be a straightforward check. And then the material requirements, you need to think, what are the key material requirements that we've got to make? And both codes have got, and to be honest, the key issue here is, does the material that the pipeline's been constructed of, is it acceptable for transporting CO2? Okay. So, to be honest, when you're comparing construction standards, the two main issues that are important, well, there's a number, but the main ones you could think of, well, what does the code say the pipeline's got to be buried at? What depth? What does it say about the inspection of the pipeline during construction? In other words, do you have to fully inspect all wells, all field wells, or not? What does it say about testing? And you could come to the conclusion, well, if the inspection requirements are the same, if the depth of cover requirements are the same, and the testing requirements of TD1 are more onerous than the testing requirements of 8010, what would your conclusion be? If you did that and that was what you found?
More conservative, I'll take a conservative one.
Sorry?
I'll take a more conservative one.
Right, but what I'm saying is, if the
That's required.
if the material is acceptable, if the construction standard in terms of the depth of cover and the level of inspection is the same, and then the testing requirements of TD1 are more onerous than the testing requirements of 8010, does that mean it's acceptable to 8010? Well, if TD1's more onerous than 8010, then it's already passed for 8010, hasn't it? So these are this is the way you've got to think about it. Okay. Right. Now, if you hit any issues where you're wanting to change the use, and the change of use means that certain things don't comply, you've then got to think about what you may need to do to ensure that the pipeline in its new use complies with the code that you're wanting it to comply with. So this is the standard list that you would apply. The majority of these issues, the first issues, will apply if you're changing the pressure and if you're changing the safety level of the pipeline. All right. If you're going to change the maximum allowable operating pressure, you're going to have to change the pressure boundaries, so you're going to have to look at that. Will you have to carry out any remedial work or repairs? You need to think about it. If the pipeline's been in operation, it will have been subject to deterioration, etc. So you need to think, well, if it's been managed such that its integrity is okay for a TD1 75 bar pipeline, does that mean it's okay for a CO2 pipeline? And then basically, having looked at all of those issues, you then say the argument for supporting change of use would be X, or the argument for not allowing change of use would be Y. Okay, you've got to make an engineering decision and explain what that is. So the activities really that you need to use, and you're going to have to build this into your approach somehow. You're going to have to do the design code checks, and as I said, I expect you to do those properly, to do them in accordance with the codes and to get the sums right. Okay. You've got to do a route survey, as we've considered ad nauseum. Pipelines are routed in third-party land and they're accessible by the public. So you can't just say we're going to change the use of the pipeline without having any idea at all where it is and what's around it and whether anything that's around it is going to cause you problems. That's why I've given you the route map and the aerial. The route map has got the detailed aerial photographs superimposed on it so that you can interrogate that. So I'm expecting you to look at the route and to decide what features has it got on it that are important for the code. The majority of them are ones that are going to be important for 8010 because that's what it's going to be operating to in future. Okay, I'm not expecting anything too detailed, but I am expecting as a minimum a checklist, and how you've gone down the route and seen which checks apply and which ones don't. So obviously, what sort of area do you think it is? Is it a rural area or is it a suburban area? Has it got any population densities anywhere along it? Has it got any special crossings, road or rail crossings? Is there any river crossings? This sort of thing. Now, one thing that you are going to have to do is review the operational records. Some of the operational data is in the design checks that I want you to do, but most of it isn't. So you're going to have to say, to change the use of the pipeline, these are the operational records that you're going to need to look at. A lot of them are what we covered in the pipeline O&M lecture this morning. You've got to go through all the operational records to say, has it always complied with code requirements? Has anything happened that may have caused damage, etc.? You're going to have to check that. That then takes you into the condition assessment. So obviously you would not do anything about the future operation of a pipeline if you didn't know the details of it, right? So you're going to have to say it's going to need a full assessment of inspection records, etc. If it's got any defects in it, which it may have, you've then got to assess those defects for acceptability at the future operating conditions. All right? You're going to have to do risk analysis because hazardous pipelines pose risks to the surrounding population. So you've just got to basically consider the key issues. What issues is the risk assessment going to have to carry out? And you're going to have to consider, because you're changing the use of a pipeline, normally that would be seen as the start of a new design life. New design lives normally start with a test. If you're complying with codes to the letter, you would say, right, well, we need to retest. So you need to say, do you really need to retest? Because I promise you, pipeline operators will never retest a pipeline if they don't have to. So there's got to be a very good reason for that. And really what I'm asking you to do in the assessment is to consider these issues and to discuss them. I'm not looking for huge amounts of discussion. I'm looking for concise, factual and logical assessments. Okay?
Regarding risk analysis, so what do we need to do there?
You don't need to do the risk analysis.
No.
You just need to think about are there going to be any infringements along the route? For example, if you look at the route and you say, right, well, the proximity distance for the pipeline, of the route corridor of the pipeline at the moment is this, and in future it's going to be this. Does that mean you've got any infringements in there that are going to need risk assessment to justify them? And then if you do justify them, you're going to have to do the risk assessment considering the hazards associated with a CO2 release rather than a methane release. Now, what do you think? Do you think a CO2 release is going to be hazardous? Right, okay. And why is it going to be hazardous? Exactly. So the criteria for assessing risk that are used for a gas pipeline, which is a thermal hazard, they're not going to apply. So you need to draw these things out. Okay. Right. Okay. So this is just a restatement of the problem. So the operator is carrying out a study to consider the feasibility of changing the use of a natural gas pipeline to transport carbon dioxide. The existing pipeline design and operation complies with TD1, Edition 5, and use of the pipeline for CO2 must comply with 8010. Is everybody happy with that problem statement?
Yes.
Okay.
Excuse me, from the previous slide, defect assessment. Does it mean something like using inline inspection to check before starting the running of the system?
you need to think about that. You need to use the codes and see what the codes would say to you. I think, my view is that most operators, if they were going to do something different with the pipeline, they would want a baseline to start that against. Okay, so they want to say, right, well, supposing the pipeline hasn't been inspected for 5 years, would you inspect? And supposing you normally inspect it every 10 years, would you inspect it before you start operating? Well, that's a reasonable position, so that you need to build that in.
So, excuse me, would it be okay for us to put that hypothetical assumption that maybe it was last tested 10 years ago or 5 years ago, or it was last tested yesterday?
Yes, you've got to, basically you've got to, what I'm asking you to do is to take that problem statement and then say these are all the issues, and by the way, Mr. Pipeline Operator, this is what you've got to think about. This is what you should be prepared to consider, and this is why. Okay, so it's your engineering assessment of the problem that I'm looking for. There isn't, you've got to remember that for things like this, there isn't a right or a wrong answer. You know, I mean, if a pipeline operator was doing this, they'd issue a contract. They may give the study to 2 different contractors, and then they choose the one that they like the results of. Yeah, that's the way it works. You know, so you've got to think in those sort of terms.
Oh, sorry. If I've understood it correct, it's like you're making recommendations.
Yes. Yeah, absolutely. It's a feasibility study, right? So the feasibility study isn't going to say the pipeline is now, its use is now changed. What it's going to do is say we want to change its use, so what do we have to do to change its use? Okay? Okay, so the information that I give now, whenever I do these assessments, somebody somewhere always identifies some information that I haven't provided. So that might happen, and basically you've got till next week to decide if there's anything that you need that I haven't given you. Some things I haven't given you, and you can look for them, right? You can look for them and you can find them yourself. We'll go through that in a minute. What I've given you is basic pipeline data. I've given you the route details. Now, the route details are constructed to some extent. National Grid provided the map and the aerial survey for me. They gave me all of that information when they agreed that I could use this as an assignment study. But the route they've given me isn't the one for the pipeline they were considering change of use of. Okay? Because it was a much more difficult route, that's why. So I've given you TD1 edition 5, I've just given you the design section of that, because I think most of what you need is in the design section. If you decide that you do want other sections of the document and you haven't got easy access to it through the library, which you didn't used to have, so I don't know if it's there now, you need to let me know and I'll provide you the other sections. And I've given you the CO2 phase diagram. Right, so the basic design data, what I've given you is the start of life and the future use, right? So basically I'm saying the pipeline was commissioned in 1974, and as of today the operator wants to continue using it in CO2 use for another 15 years. Okay? That's important because I'm expecting you to do some fatigue calculations. All right? Temperature. Basically, it's under gas use, the compressor discharge temperature, the maximum temperature of the pipeline, so this is 35 degrees C. Otherwise, it's going to see the ground temperature. Okay, so you need to consider that. That's important when you start looking at the CO2 phase diagram. The outside diameter is 914.4 millimeters. The wall thickness, the standard nominal wall, is 12.7. Now, that's one of the bits of information I haven't given you that you need to look at. When you look at the design calculations for the pipeline, it will tell you to use minimum wall, not standard wall. So you're going to have to find out what the minimum wall is. And what I suggest you do is assume that the pipeline material was supplied to API 5L You need to look on the internet and get API 5L and then find what the manufacturing tolerances are for a pipeline of that size. The proximity pipe, that's the thick pipe, which will be present under road crossings or wherever there's any pinch points, population density infringements along the pipeline.
Sleeves, yeah?
Sorry?
Is it sleeves?
No, it's proximity pipe, so it's thick pipe. Right, TD1 at the moment doesn't advise using sleeves to protect the pipeline. It says wherever you need to have a high impact resistance, you put thick wall pipe in.
So this proximity nominal thickness is also a standard, right? Standard nominal.
Yes, that's right. That's the standard nominal. So and what you need to use for the calculations is the minimum. Right, I've given you the depths of crossings, etc. That's important because if you look at the design section, it'll talk about depth. And I've said the current operating conditions right now. This is actually wrong because I've used 70 bar here. That should be 75 bar. Okay, so please assume that the pipeline's operating at 75 bar. It's been seeing a daily pressure cycle of 10 bar for its time in operation, and it's been seeing 25 compressor cycles per year of 20 bar. Okay, so you need to look at the fatigue of the pipeline using those conditions. That will then tell you, have you had any significant fatigue damage, and you then need to think, are we likely to get any fatigue damage in the future use? And
This is the whole presentation, to be honest. Dissertation.
what absolute rubbish! This is easy.
No, that's the whole dissertation.
Now look,
No
other
experience.
groups of students have done similar things, and some of those groups of students were not at all like you lot. You'll have no problem with it. Sorry, somebody was going to ask.
Yeah, I was going to ask that. I really don't understand daily cycle. Can you explain much more?
Do we do it?
You need to look at the fatigue section in TD1 and work out how to calculate it. Once you've looked at the code and the code tells you how to do it, yeah, there's a formula in there. Yeah.
So you mean the daily cycle 10 bar and then plus the additional
Yes.
cycle?
Absolutely. Right. So basically, what that's saying is your fatigue stress is whatever stress a 10 bar cycle produces, and you're going to have 365 of those in a year, multiplied by the number of years it's been in operation, and then plus you're going to have the 20 bar cycle. Hey, now look, I can't cope with this. I can't hear what any of you is saying. Right, so are there any other questions on this that anybody wanted to ask?
The current year is 2017, right?
Sorry?
We are considering 2017 as the current
Yes,
year.
yeah.
Excuse me. Is it important we get information on the design life when it was intended? The life it was designed for.
Well, it doesn't really matter because the code has got an SN curve in it, which will then tell you how much fatigue damage you've accrued. So yeah.
Sorry, we missed regarding the cycling, daily cycling, 10 bar, yeah, we missed talking about it.
Yeah. So what you need to do is find out what stress a 10 bar pressure is going to introduce in the pipeline. That's the daily cyclic stress range. So it's going to see that stress multiplied by 365 days each year, multiplied by however many years it's been in operation. Then you need to do exactly the same thing for the compressor cycles, but that's on a yearly basis. And the formulae for how to do it are in the code. They're in the design section of the design code that I've given you.
And regarding the pressure cycle for the CO2, do we need to assume?
I think when you start looking at that, you'll soon work out what you've got to do. Right. Okay. So this is essentially what I want you to do, and really what you're going to get marked on. All right. You've got to identify and describe how the feasibility study for change of use has been carried out. So you've got to, as one of the first sections of the report you're going to do, you've got to explain to the operator how you're going about it. You don't want to keep them guessing till the last page of the report and then them thinking, all right, so that's what they were doing. You've got to tell them up front how you're doing it. All right? Then there are some standard preliminary design checks which you must do and you must get right. And these are, you've got to select the maximum operating pressure. You've then, having selected that, you've then got to calculate the design factor, and you've got to calculate the fatigue usage based on the pressure cycling that we've just talked about. Okay? Then you've got to explain what other things need to be done, and you've got to say, do you think the change of use is feasible? And that is your engineering judgment. Based on what you've looked at, that is your judgment. Okay? Your recommendation to the operator. And then having got to that stage, you've then got to say, right, it's feasible, but in order to do it, these are all the things that you've now got to go away and do. Some of them will be high cost activities. They may involve replacing part of the pipeline, they may involve doing a new inline inspection, things like that. So it's not just right, it was gas yesterday and it's CO2 today. It's not as simple as that.
So regarding this maximum operating pressure, so are we, when we're doing calculation in consideration about this maximum operating pressure, we need to actually take it from the test data?
Well, let's just think about that. Let's think about what information you've got. Right, you've seen you've got these. I will come back to that. Okay. What this? I think I've put these in the wrong order. This one's easiest to see. Right, this is the map. Okay, and this is the pipeline route here, shown in blue. So you can see standard ordnance survey map giving you details of everything that's around there. And then the map with the aerial survey photographs superimposed here, and what you can see, or what you'll be able to see if you blow this up on your screen, the pipeline route is there, and it actually shows the proximity distance and the route corridor there. So don't bother measuring them and checking them, just assume that they are correct. Okay? So that's basically telling you what's in place there for the gas pipeline. Now there are a number of things that this map shows, or the other map shows as well, and I always forget what these are. I expect you to look at what these are and decide if any of them are important to the assessment of the route. The SSSI definitely will be, that's that one. That will definitely be. I can't remember what these other ones are, so you just need to look them up on the map key and see if you think they'll be important. SSSIs are always important, as are basically developments involving people. So not so much. This one goes on about listed buildings and things like that. Anything which is environmentally or safety sensitive could involve lots of money to deal with, so it's important that you flag it up. Okay? Right, so now let's look at the CO2 phase diagram. Right, now CO2 is a bit of a difficult substance to deal with, because basically we start from the triple point, and then we start to move up towards the critical point, and we've got a gas-liquid boundary. Okay? So this is really tedious, because it means that if you are somewhere on this pressure axis, and you change the temperature, you're going to change the phase of the fluid. You don't really want to be operating a multi-phase pipeline, certainly not a multi-phase onshore pipeline in the UK.
There was a range of temperature.
The range of temperature that the pipeline could see is in the data table. So what I've said is that typically the ground temperature, most pipelines, once you're away from pump stations and compressor stations, most pipelines will gradually change to the ground condition temperatures. So assume that this pipeline is going to be, the temperature of it's going to be dominated by the ground conditions, which I think I've said are 4 degrees to 13 degrees. So basically that's the temperature range that you're going to go to, which means that's the pressure range. But remember, you've either got to decide we're going to operate in as a dense phase pipeline, which means you've got to be above this pressure, taking account of all of the code requirements for controlling pressure. So you need to look at the pressure definition diagram in PD8010, and you've got to say, right, it's telling you you're going to have to set an MIP, which is going to be 10% above your operating pressure, and then you need to think, can I actually operate at this pressure? And of course that depends on what the design factor is. You calculate the design factor and check. If you can't operate in the dense phase, what is the maximum pressure you can operate in the gas phase? And remember, there's no point in saying, well, you can operate at a pressure like this, because it means as soon as you drop the temperature, you're going to convert from gas to liquid. Okay. Right, let's just have a quick look at the TD1.
Sorry, question regarding this density. I don't understand acceleration with density.
Carbon dioxide is quite an unusual substance, right? So it's basically, most substances have got gas, liquid or solid phases, all right? CO2 has got all of those, but it's also got what is called the dense phase, which means I don't fully understand it, because it's basically it's a chemistry type issue. But what it means is that once you're above these conditions, so once you're above that pressure there, which I think is something like 73.8 bar, once you're above that pressure, it will operate in the dense phase regardless of the temperature.
So it is like mixed phase?
I think if you look up dense phase, it will say that it's got the density of a liquid but the viscosity of a gas. So it's sort of like a funny state. And in reality, dense phase in any fluid is usually the best phase to transport it in. It's the most efficient phase to transport it in. But the issue you've got here is, ideally you would be wanting to transport in this phase, but the pipeline's already there, so you're already stuck with the diameter, the wall thickness, etc. So can you actually operate that particular pipeline using CO2 in the dense phase? You need to think about that, and you need to explain your logic.
So that means that if we cannot operate at dense phase, we need to operate at vapor phase, and we have to justify that.
Yeah. Yes. If you can't operate in the dense phase, you've got to operate in the vapor phase, and you've got to say, if we're going to operate in the vapor phase and we're going to remain in the vapor phase at all times,
you can go higher than that.
You've then got to say what's your maximum pressure that you can deal with. Right. So if we just have a quick look at the TD1 design section. Right, we'll have to do that. Right, so you need to go through this and decide which bits of it are relevant to this this change of use. A lot of the early stages you're already stuck with because the pipeline's already been designed and it's there. So you don't need to worry too much about those. The loading on the pipeline is important. You need to check, well, this is what the TD1 design would have required. What would the 8010 design required, and does 8010 require you to do anything in addition? Right, now you've been asking questions about the fatigue. So the fatigue section in TD1 is section 6.6, and basically what that does is it's got the simplified SN approach in, and this is the approach I'm expecting you to check the numbers against. It's given you the SN curve at that in that equation. Then it gives you the criterion, which basically means you've got to calculate the damage fraction for each set of pressures that you've got. So you'll have a damage fraction to calculate for the daily 10 bar cycle and a damage fraction to calculate for the 20 bar compressor cycle, an annual damage. You've got to add them together, and then you've got to decide, is that acceptable? Has it been accumulating any fatigue damage? And you also need to think about fatigue in future life. By this stage, you will have decided what pressure you're operating at, and what you can say is, right, okay, it can't see any pressure swings, or let's assume, well, it is going to see, because any operating pipeline is going to see some pressure swings. So you then need to say, if you ended up putting it in the same sort of pressure regime that it's been working in for natural gas, you could say, well, let's assume it's going to see the same sort of cyclic conditions. If you end up saying, actually, it's going to operate at a much lower pressure, because we're going to keep it in the gas phase, you might do a fatigue damage calculation and say it's not going to see any fatigue damage in that. But you've got to do the sums. You've got to do the sums to prove it. Right, the next thing that you need, so there's the fatigue curve that you need to use. So I think all of the information on doing the fatigue analysis is there. The other thing that you need to do, while the proximity distance is shown on the maps, I do want you to calculate the proximity distance for the pipeline. Okay, so this how you calculate the proximity distance is in the section. It'll be on what is page 44, and it's got the proximity distance equations in. So you know that the pipeline has been operating at 75 bar. You know what its diameter is, so you can calculate what its current proximity distance is. Then you need to calculate what a proximity distance would be when you've changed its use to CO2. And you're going to have to go to the 8010 code to calculate that. Don't look so distressed about it. Using engineering standards and codes is fun. Put it this way: if you don't think it's fun, you do need to use them. And once you have got your head around using codes and standards, you'll find that it's certainly not as bad as you think it is. And if you really want to earn any money as engineers, you've got to do it anyway. So, right, I think that's probably all we need to do.
What's the deadline for that?
Narracorn has set the deadline, and I think he did say he was going to write out after this session and confirm to you exactly what the marking scheme is and what the deadline is. I think it's the 27th of April, but I'm not sure.
That's right.
Good.
It's all right. I think it is, but we'll perhaps need to check.
About the page, how many pages?
I get asked this question every year. I mean, to be honest, I don't mark it based on the number of pages. I'll mark it on the structure of the report, the sections you've got in, and the information you've got in. Typically, these assignments, I'm trying to think what they were, they're typically minimum around possibly 20 pages. Some of them are much, much longer because some people, when they're doing this sort of work, they collect lots of information from standards and codes and other things, and they put it in as appendices. Right?
I have not done this program before. Why are you waiting on me?
That's what you do, is it?
Yeah.
Oh. Right, well, all I can say is think about it from my point of view. I'm going to have to mark them. Now, do you think I'm going to like marking a 20 or 25 page document or a 100 page document? I don't particularly want to mark a 100 page document, but equally if the 25 page document's got some significant gaps in it, that's not going to help either. Okay, so really this is your judgment. This is an engineering problem that you are looking at, and the key thing here is to get an understanding of how you're going about approaching it. Have you all got your groups sorted out? Right, now this has always been run as a group exercise, and the logic for that, the disadvantage of group exercises is once it's been marked you all get the same mark. So if some of you have done lots of work and some of you have done very little work, swings and roundabouts, isn't it? It means that once you've decided what you're going to do, first of all, if you're doing it in a group, you can discuss the approach and you can agree the approach, you can challenge each other on what you think needs to be done. And then having decided what you're going to do, you can actually split up the tasks and not everybody has to do everything. You could split up the tasks and say, you do this bit and I'll do that bit.
And is it only a report or presentation?
It's only really a report. So this isn't assessed by asking you to come in and do a presentation. At least historically it hasn't been, and I don't think MAR has changed. So basically, you will need to submit it as both an electronic document and as a hard copy document. Okay. Right, is that all right? Right, now what I suggest you do essentially, I think you probably need a break before Gary Anderson comes. He's due at 3:30. So for the next few minutes, what I suggest you do is spend some time looking at the phase diagram and doing some basic design factor calculations. Okay, and if you've got any queries or anything you want me to go through again, then just tell me. Pardon?
That was
You want to?
I think we buy by 59. I think that was also
Or we can send our work to each other after a week. We will read each other's works and our work once, and then we will discuss. Take. Your investigation essentially the MAOP is the highest
What is it currently?
I think
Oh yeah, I can
very aggressive. That's why it's going to be.
Okay, so we can responsibility.
Okay, yeah. Not really possible, how we're going to spend the population distribution how many years ago?
Along
Guys have I saw yesterday.
Excuse me, is it written there on the map? For example, 1 centimeter of the map is actually 100 meter, for example, just to count it. Is it?
yes, I think the scale should be on the map.
Is it?
So according to the code, it will be able to tell us the sections, how we isolate sections to be able to calculate the proximity distances.
Right. In terms of calculating the proximity distance, what you need really is the design factor. So you calculate you get the proximity distances by looking at the diameter and the maximum pressure, and then you use the proximity. Have you got
From the code, the other chart, which has the diameter and the operating pressure.
That's how you use. That's how you calculate the proximity distance. There's an equation on that graph which tells you how to calculate.
That's the one according to the code, like the proximity distance which is recommended by the code.
Yeah.
But I'm saying from the map for us to be able to see whether it is actually.
Maybe you are not maybe location classification.
Yeah, I don't think you need to worry about that. The map has got an indication on it, right? And I would just use that as a guide. I'm not expecting you to measure it and say that it's accurate or not. Okay, just use it. And the best thing to do really is just to follow the route of the pipeline and see what's there.
There are any developments along the
exactly.
pipeline. There are any
Yeah. Because what is a problem at 75 bar natural gas? If you decide that you're going to operate in gaseous phase CO2, you might think, well, that's not a problem, because you have to recalculate the proximity distance using the equation in PD8010.
Thank you very much for this time. It's going to be very useful.
Good.
I think by the time you come up with this report, this document, the knowledge is enormous.
I appreciate it. Well, I'm pleased that you think about it like that, because it's not really intended to be a big problem to you at this stage, but it is supposed to be giving you good experience.
How to manage with the standards.
Yes.
How to calculate everything.
Yeah.
It might be a little bit tedious, but it's okay.
It might be a bit tedious. Using standards and codes is always tedious at some point.
Reading a lot, trying to but it's good at the end of the day.
Thank you very
Good.
much.
That's good.
Yeah, just discharge. Yeah. Is it GoPro? Is this Pro? iPad Pro? Yeah. Maybe it's not. Yeah. I think this is only Pro.
And you're the only one who's like, that and whatever. I think you've got it. I've got it. It's actually competition.
That's right.
This should be finished. We've done all. Yeah. He's boss. He's leader. You can just assist him.
I'm the grand leader.
Yeah, grand leader.
I only count what he's doing.
Oh yeah, just sleep.
This is a good leader. He tells us you do everything.
Take a rest.
I will do one. I will do all.
We've definitely got a short straw at the end of that.
It's so small. You've seen it. It's so small.
I think I'm too big for it. I'll let somebody else do that.
Not the library design finish.
You can make.
I know you will go to the library design.
Yeah.
No way!
Yeah, that's what I got. No. I travel tomorrow, and then it's all day tomorrow. And basically, I only went weekends like that. Basically, my contract is not. I would presume it's the next day. Yeah, because like.
But then they should just
No, he literally said, I think that you're free on the Saturday, right?
You can use it. Maybe it's cut. £3. 5 minutes. Yeah, 3 meal.
I think you need one.
But to be fair, I got it wrong in the sense that it starts.
What did you
July
eat?
from Sunday, so that's not bad anyway. But then you run conflicts with that.
Just don't get a house.
Angel said
I'm going to message why you and that says that you have to do it.
Is it okay?
Throwing mouth, eyes here, nose here, mouth here. Maybe tremors. And without hair. My eyes. You need to go with them. Nose here. Nose. My mouth eating and I got yeah, and I got it yesterday.
But I'm going to go back to the let's get that check for.
Yeah, when you install
You're going to
Really be sure. Chinese is working tomorrow, right? We are asking
yes, but now not bigger than
But we just discussed that. I got my times wrong.
because he's going to be leaving 25 minutes. No, we have to the picture actually. Yeah, that's true.
Here we go.
You are one for this week.
Right?
Ah, okay.
So, he is Jay and Carl and myself.
Really?
Are you going to Nigeria?
Uganda.
Uganda.
Free etiquette.
Yeah, so
Oh, really?
then
Then invite me.
you
Why
think
not?
you
Me.
think why?
Because I like Uganda. How many hours flight?
It depends.
Restriction.
I
Right,
think
left.
currently we have a direct flight.
Ah, okay.
No, Canada.
Canada.
From where? Canada.
Answer.
Comes from Amsterdam.
No, but there's no direct flight.
Of course.
Yeah,
But the
that's
easiest
what
my point.
Ah, okay.
Right, left.
by left or by right. You can fly south, you fly north.
No,
Is it
you-
Fly to China first.
Ah.
China to Manchester.
I don't know, we were looking at the flights for car from Egypt to Uganda. Usually it will take, if you fly from Cairo to Uganda, it will take about maybe about 5 hours. So
It's not
one
far.
of the flights was Etihad.
Etihad.
From Cairo to Qatar. Then from Qatar to Tuesday.
Richard, who's coming to Qatar?
No, listen. We're moving from Cairo to
He only had to. He only had to video anything.
relax, just so from Cairo to Qatar, from Qatar to
Where is the Cairo? Qatar.
Therefore, I tell them to shut down the runway.
So when you're going to change which airline will you
Air China?
No. It's
Not
expensive.
bad.
Yeah, yeah. Southern China.
yeah.
Southern China.
from
Southern China?
direct
From Manchester to Beijing, or from Manchester to Hong Kong. It's not directly to my hometown.
how do you get to your hometown?
By train from Beijing, train or by flight. By flying is 2 hours from Beijing to Hong Kong. Train 10 hours. And it's far. It's almost from here to France.
Morocco from
No train.
Only flight. World Cup.
Yeah. How much time?
Is it possible to take a
Nothing is possible. Impossible. Nothing is
You will eat it by lions.
Too expensive.
1 week.
Okay, you
It's
why
possible,
would
it's
you?
possible, but I will do.
Yeah.
How much?
If it's an explanation.
More rich.
No, I mean,
Are you gonna pay rich? Rich man.
No, let it be rich.
South Sudan, Kenya.
how much from London to
London to
20 pounds?
yeah, 20 pounds.
Can you go?
20 pounds?
Yeah, 20
From
pounds.
London to Morocco?
Yeah.
Yeah, it is strange.
It's good.
Morocco is in North Africa, and North Africa. That's the water.
But from Morocco to Uganda.
That's still cheap.
You need a visa.
More space now.
Everywhere. Everybody need visa.
Yeah, I didn't even find that. And it's going to be pretty Friday.
유네요. 뭐가 과자니까. 아, 저거 엄청 컨실해야니까.
Richard, do you think I can shower every day if I go to Morocco? That's a
Really?
problem for me.
Literally,
I
right?
need to shower every day.
Well, do you go to shower every day?
Every day.
Every time. We do the shower every day.
That's
Take a
it all.
shower in
Okay, wait. Do you
You
shower
need
every
to book
day?
a hotel
Oh,
during travel so you
that
can.
too.
Is it? So if you're in Morocco, you shower twice.
Yes, I know.
What? Yeah, it might be hot, yeah. It's not compulsory, you don't shower twice, but it's better to do
Yeah,
twice.
take me to Nigeria.
You go to Nigeria,
Nigeria?
you have to shower twice.
Oh, let's
Shower
finish
twice.
Europe first.
Yeah,
I
why
will
is it
travel
only
to Europe.
Ah, really?
You wanna do what?
I will travel in Europe this Easter holiday, maybe next holiday. I will try everything. Oh my God.
When it's hot, it's not beneficial, you are
Many Chinese, nowadays many Chinese go to
normally,
Kenyans were getting
of course, but in Nigeria, we are in traffic.
Yeah.
Okay, yeah. If you're home, you don't have to for some people to feel comfortable. Like my dad, we
It's
have twice. Once from once it comes from because you have shaken some people. It's just
3 hours but it's not.
imagine when you are now sweating.
Ah.
Because we are trying
5 hours is just from the southern base to northern base.
Inside China. Nigerians usually
From my place to Guangzhou, it takes 6 hours.
inside China.
You're really very far off.
Yes,
So you don't want to
it's
shower.
to Hainan,
It's just
the soft place.
when I say
8 hours. City.
Do you need visa to go to Nigeria?
I think so.
No, I don't think you need to be honest. She needs visa to go everywhere. No, because China, the last one we get was in Nigeria. Maybe extension.
I don't know. I don't know. But if I
You can go tomorrow. You can.
Finally.
Need more festival.
Bye. I'm leaving.
I will do it because she's cold.
They decided to balance out.
This is Nigeria. It's just like
Are you using your laptop or do you
I
want
can
to?
do either. I put it on a memory stick. That's easy.
It's whatever. Well, I've been using my laptop, but this is easy enough to use, so it's whatever you want.
I'll just, if I can run through a memory stick, I'll just run as it's easy.
Right, okay. Could you sign on so that Gary could put his memory stick in? They're supposed to organise that.
in China it's Tianzhong. It's not
Thank you, that's
Yeah.
great.
Tianzhong. Your pronunciation.
Yes. 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 My pronunciation is right.
No. It's the same as last year.
Well, no, that's good.
I was going to try and amend it a bit next week, but I would bring it forward. I've been travelling the past 2 weeks, so I couldn't.
Thank you. They seem to be really keen and interested to know. There's a USB on the top. Hopefully you're less likely to walk out and leave it. I've done that several times before.
So difficult. The visa to go to your other countries is only between 3 months, 6 months.
Yeah, because it's on laptop, so it just needs to be switched onto the PC.
Should I put on PC? That'll switch it
Yeah,
over there.
I'm just going to need to fill you up.
Yeah. Do you want me to wait till you get back? No.
Well, I think your lecture's due to start.
12 at once.
Well, it's just something that's disappeared, so.
All right, okay.
But they should. If they're not back by 1:30, then they're going to miss
Well,
it.
yeah, that's fine. No
Give me visa. Receive Okay. How do you know? Facebook. But it's not okay. Well, now it's a serious.
그리고 제가
There's a human in the family. It's a woman. Yes, that's my reason. Just you. It's reasonable. So my husband's alone will divide it into 2 months.
It's just the offshore pipeline technology conference in Amsterdam.
Oh, right.
Really good actually.
It was good, was it? It was well attended.
It always, we were presented as well, so it was always good. I saw him. Do you know John Healy?
Yes.
I used to work with John, and I didn't realise Dave Jones was working with you. So I was asking how Dave was, and he said he's been working with you.
Well, he has. I mean, Dave's actually retired, and I feel like I put pressure on him to say we've got this project, Dave, we really want your help. Actually, I think he enjoyed it and we did work very hard on it. It was the national grid and electric CO2 transportation.
Right, yeah.
And Dave got involved with all that, all the fracture propagation stuff, and he was excellent. But he's, last time I spoke to him, which would be a few weeks ago, and I don't think he's looking for anything at the moment. He seems to be okay.
Oh, if you speak with Pascal,
I will do, he's a lovely guy.
Oh, he's great, yeah, I was actually going to contact you. I tell you what, your PIE came up when I was down in Harrogate, just in like an open evening. I was interested in going down and seeing on the new inspection technique for AGIs.
Oh, it's the one that Synthetech.
Yeah. The reason I was interested in it is we were interested, we went down to National Grid in Birmingham Way, Warwick. And they mentioned we've got a design theory concept that we want to take it onto the onshore market for isolation of pipelines onshore. And what they mentioned down there was almost the competition, if you like, or the award which goes out with Synthetech won. And we were keen to see how we would get involved in that and how we would approach it. National Grid felt that we had something in the project, and they suggested going into this because it would get funding for it, so we were trying to work out how we get into it.
Right, okay, well basically they offer this, they run this scheme, I've forgotten its name, it used to be called the National Innovation Award Scheme, and it's basically they come up with a project and it's all got to be properly costed and everything, and then they go to Ofgem and get the money for it. So certainly I do think that one of the issues that has occurred with this great project talking about is getting access to the pipeline. So if that's something that you could be, you might be interested in.
Yeah, we, as I say, it's a completely different project, but it's something that we really want to look at.
Right, well, Gary Senior, who you know,
I know Gary.
I mean, Gary's involved with a number of NIA projects for National Grid, and Gary is well respected. So if he comes up, have you got an idea?
We've got what we want to do.
Right, and have you turned it into a proposal and you sent it to them?
Not yet, that's what.
Right, okay, well, basically what you need to do, the best thing is to look for an internal sponsor. But if you haven't got an internal sponsor, then you send it straight to their innovations manager, who will then bring it under.
Well, what they said was that we gave them the idea, and they said you need to take it a little bit further forward before you bring it back to us. So trying to find the time to go back down to Warwick and present it to them and see where we go from there. But it was just when I wanted to go down to Synthetech to see how a bit involvement, see what they've done, and obviously the idea came up, and I thought, I'm going to help it.
So have you been to Synthetech yet? Because Gary could say, right, you have.
I have been down to see it. And in some ways it's not so much the project itself, it's just how they got into it and how they got the award put forward. I might give Gary a call, I'll drop him a note.
Gary is, he knows a lot more. I mean, I suppose of the two of us, I was the first to get involved, only because National Grid had a specific idea and said, we're interested in you and somebody else doing it. Gary has been much more involved in the setting up the project and how it goes, so he could provide a lot of it. Have you got a sponsor? Do you know somebody internally yet?
Within National Grid?
Yeah.
We've got somebody who, like an individual name.
Yeah.
Yes, we've got a name who said they were looking, they suggested the whole thing too.
Right.
So it's Peter.
Not Peter Martin?
No, it's not Peter Martin, it's just a young guy out there.
Right. Well, I mean, if you've got a name, that's the first step, because basically they then sort of sponsor it internally for you, you know?
Right, okay, so I need to get back to him anyway and do it. I was just rather than go down and he starts, you know, we need to do this, I'm just sort of picking people's brains as to how the Synthetech project came about, how we got it
Well,
done.
Gary can probably give you some guidance on what proposals look like.
Right, I'll maybe drop me notes. And,
Well, I'll be in touch with him after, so we'll normally have a long catch-up call on it. Did you know that Gary's been ill?
I had that, somebody had mentioned it, but
He had a stroke.
as recent as that.
Yeah, it was, what a fright it gave everybody. I mean, you know, he's had health problems in the past. He's got none of the triggers that you would think he was doing. Anyway, he's recovering really well, and he is working back working again now. He's working more from home than he did, because obviously he needs to be very present.
Okay. Oh, well, if you wouldn't mind have a word on that, I'll let him contact me then if he's that suits rather than put pressure on him.
No, I mean, he'd be, don't let me give you the impression that he's ill and he couldn't contact him. He's not. And he would be pleased to hear from you. I'll certainly do that.
Please, it's certainly something of interest for us. We're pushing to get this development, but it's obviously the funding of the current climate is it's difficult for me to go and say, right, I need $5 million of funding to get this sorted. And so we've got partial funding from a client, but it's an offshore project, and it's the development is getting us close to what we want to do onshore. And then it's fitting in with the onshore regs.
Well, it sounds like the ideal topic for something.
Well, they suggested it to us, but Pete has sort of said, look, this is what you need to do, go into it.
Brilliant, right, well, I'll mention it to Gary. I'll get him to drop you a line so you're in contact with him, but you know, he is very well informed on things like this. Well, we better start, don't worry about late. Right, everyone, are we ready to start again?
Yes.
And is there a spare seat somewhere that I can use?
Someone?
A spare seat?
Use this one if you want to.
You can go and sit on here.
I'll just answer. No, I'm going to sit on the back. That's quite all right, thank you. Right, can I introduce Gary Anderson, who is with TDW, who are world leaders in hot tap and stoppling. And so you are very lucky to have somebody like Gary come and talk to you.
Thank you very much. Thank you.
Please pay attention, because this topic is on the exams, all right? Thank you very much, Gary, that's great.
I'm assuming if I press that,
It should come on. Yeah, you're okay.
Right, thank you, Jane, for the introduction. As I said, my name's Gary Anderson. I'm actually the Offshore Market Development Director with TDW. Most of my role is in the offshore market, but I'm going to cover what we do in the onshore, more onshore with hot tapping and stopper. So the title is Intrusive Pipeline Intervention and Isolation, which effectively is its official terminology, but we will call it hot tap and stopple, and stopple is a brand name of TDW, but it's used around the world by other companies as well. As much as we sort of object, we don't object, because it is a recognised terminology. So what hot tapping is, it's basically a method of drilling or cutting a hole in a pressurised pipeline, an operating pipeline, and containing the pressure release and allowing further work to be carried out. And stopple is a method for temporarily isolating that pipeline by plugging it, and we would plug it by going in through the drilled hole, and that would allow modifications to be done on the pipeline itself. So I'll come on to them, both these subjects, in a little bit more detail. Is that too bright, or can everybody see that okay? Or do you want the lights down, or is it okay?
The lights are fun. If you try to put them down, it will just go off.
It's okay. If it's a bit dark, we can switch it. If it's a bit bright, we can switch off if you want. It's up to you.
With the light switch.
Jane is alright.
Just try it. It's one of them.
That's better. Yeah.
Is that better?
Yeah.
Right, so just quick run through, why do we hot tap and stop up? So why do we contain the process? So typical modification in somebody's house, drill a hole in a wall. Unfortunately, behind that wall, you'll often find there's a lot of pipe work there. And what can happen is there's water released. So something like that in a property, it just means a flooded floor. We can mop it up, we can stop the flow. Not that big an issue. You do that on a pressurized pipeline, it's got a lot more significant and serious consequence. These pipelines can run certainly well over 1,000 kilometers without any valve work in between, or certainly on the offshore side. So that's a lot of release of product, and it's impossible to stop once it starts, or virtually impossible. So the applications we use it for is, if we've got an existing pipeline, we can connect into it, we can tie into it, we can modify that pipeline, we can change valves or any equipment which is on there. We can divert the pipeline, so we can change its direction, and we can also replace damaged sections. And then obviously fittings which are on that pipeline, we can repair them whilst the pipeline is still in operation. So what products would we use it for? Typically, I'm more referring to TDW, but generally in the oil and gas business, we can do oil pipelines, we can do gas pipelines, chemical pipelines, and we can also do water pipelines. So hot tapping can also be considered for pressurized water pipelines. And the type of pipelines we can drill into: carbon steel, which is typically what you'd see in oil and gas, cast iron in older pipelines, plastic pipelines, we can do that, and also again, this gets back to the water industry, we can do concrete pipelines as well. This is a typical site setup. This is a gas or an oil pipeline. The idea being here is we're going to be doing a repair or a replacement on this valve. I'll just let you look at that picture for now, because I'll go through the presentation, and hopefully by the end of it I'll bring the picture back and you'll have a lot more understanding of what's going on here. But that is a typical site setup for a hot tap and stopple operation. Involves a lot of digging of holes and a lot of welding and a lot of pipe. Specifications are one you can do. Typically 1-inch diameter pipelines right up to about 120-inch pipelines. So that's, from the small to the extremely large. And the tap size, so that's the hole that you would put into the pipeline, again is typically from about 1/2 inch through to 102 inch. And the pressures that we can work through, so this is the pressure that's in the pipeline when you drill into it. On 56 inch and smaller, you can go up to about 1480 psi, which is 102 bar. There is specials can be done. We can obviously extend that range and go up to 153 bar, 2220 psi, and that would require special equipment, but it can be done. And again, temperatures, typically we can go up to 537 degrees Celsius with special equipment, and these figures are figures of projects that's actually been done, so the real life figures. So what is a hot tapping machine, or what is hot tapping equipment? And effectively it is a drill. So what you have is the drill itself, or the drill machine, the tapping machine here. The reason it's long is because the drill has to often travel quite a distance to get into the pipe, and it has to go through 1/2 of the pipe. You then got what is called the cutter holder, and then you've got the cutter itself in this area, and it has a pilot drill, because if you're drilling a big hole, it's not a drill, it's a cutter, but you need to have the central pilot drill to keep it in the middle, and that also acts for another reason which I'll come on to later. Sandwich valve, term sandwich valve, it's an isolating valve. The reason it's called a sandwich valve is it's very thin. So we think of a sandwich, 2 slices of bread with something in between, whether it be cheese or meat. The valve itself is the meat, and it slides in and out. The reason it's thin is just to save space, because this can stack up to be quite a height. And it's a temporary fitting. It's not generally classed as a permanent fitting on the line. Oh, sorry. The fitting itself is key to the whole exercise. If you get the fitting wrong and you don't put it on right, then everything else you do is wrong. You will not be able to rectify it. The machines themselves, obviously, depending whether you're drilling a 1/2 inch hole or whether you're drilling a 102 inch hole, it will vary the machine you're going to use. And these are T.D. Williamson machines, so the terminology is brand names. So a T101 is just a reference to a machine that we would use. And as you can see, the T101 is at the very small range, and it's actually a hand drill. It's not a machine drill, it's a hand drill. And obviously the bigger you go, the more complicated the machine becomes, and the more power generated the machine becomes. And we can go higher again. These are really heavy duty stuff that we use, and really this is just showing you the examples of them. There's not too much significance because the project will dictate what machine you would use. And if there's any questions anybody wants, just feel free to shout out through it.
Okay, which one will you use for like a concrete coated pipeline?
The machine itself, you can use any of them. It will depend how big it is. I mean, obviously, it will be the larger sizes. So probably this has got the T2400 goes up to 60 inch, but there will be extensions of that, and we would use it. When you get up the really big sizes, they become very special machines. They're not off-the-shelf machines.
Are there challenges actually with concrete pipelines, like breaking off the concrete?
Not really, because the cutter you use will cut the concrete very cleanly. Yeah. And it's, generally speaking, if it's a pressurized pipeline of concrete, the concrete is in good quality. So it generally won't break away.
You mentioned about temperature, 537, if I'm not wrong. So can we use it for the HP steam slime?
Can we use it?
HP steam.
There would be no reason you couldn't. No, as long as the temperature was within the range of the machine, there's no reason we can't tap into a steam line. These are the fittings I talked about. As I mentioned earlier, they're really key to the whole operation, and the fitting of the fitting is crucial to the whole thing. Because you've got to remember, once an operation like this goes on, that fitting will remain on the pipeline. It will become an integral part of the pipeline. So when obviously the course you're doing will cover pipeline integrity. That fitting has to comply with the integrity of the pipeline after the hot tap company will walk away. They can't take it off once it's on. So there's various, obviously depending on the requirements, there's various options of doing this, but typically the vast majority of them is this, which is just a welded fitting. So it's a shell fitting which goes over the pipeline, and it is welded and sealed. And obviously this area here is where the tapping will go through, and I'll come on and show that a little bit more detail. As mentioned, these are the fittings themselves. So obviously, as you can see, this is the pipeline diameter, which would straddle over, and this is actually the tap diameter. So that's the hole size in there. So we can do the hole sort, what we call pipe on pipe. So if it's a 24-inch pipe, we can do a 24-inch drill in that. But obviously, what that means is that hole is 24-inch diameter. You obviously can't do bigger than the pipeline diameter. So the fittings that you've got, these are just typical fittings. So you'd have a standard fitting, or you can have a valve use, so that's when it becomes more permanent, and that can be either a ball valve or a gate valve. And the stopple fittings, obviously for the insertion of the pig plugging head, that has to be size on size. If you're doing a stopple operation, if you put in a 24-inch pipe, you have to put a 24-inch plug into it. There is slight variances in that in the very big ones, where you can have folding stopples, so they can actually they almost fold in half, and they can slot into the pipeline, so they don't necessarily have to be pipe on pipe. But most of the time you do use pipe on pipe size. As mentioned earlier, the criticality of the fitting going on right is so important to the installation process. So this is just a typical site setup, and you can see the welding occurs around the outside, so that will be either side, and then it will be across the middle as well. This is obviously the area that we're going to be tapping. So the orientation of it is obviously key. if it's a 12, this is a 12 o'clock fitting, so it has to be exactly at 12 o'clock. Because if it's slightly off, that means the branch that comes off will follow that route.
So before you take this out, if when you are accounting for this kind of project and you have external coating on the pipeline,
that has to be cleaned off.
Has to be cleaned
Yeah.
off.
So what will happen? It doesn't show it. Doesn't show it very well here, but that excuse me. That pipeline has been thoroughly cleaned. You can just see the coating there. So that's the coating which will have been removed to allow the welding. Because the welding itself is to follow obviously strict welding codes. The welders who do this have to be certified specifically for doing this operation. And after the welding's taken place, there is a full NDT goes on here to ensure that that weld is correct. As I mentioned, that has to remain on the pipeline, and the integrity of the pipeline will be affected by the integrity of that fitting. As mentioned, the sandwich valve, you can actually see it a bit more detail there. This is the meat in the sandwich, if you like, and that's actually, it's wound out, and the reason we do that is as the whole operation goes on, it allows us to isolate it for a period of time while we change equipment on the hot tap. So if we were switching from the tapping machine to the stopple machine, you use the sandwich valve for that purpose. And that sandwich valve would come off at the end of the operation, so it's a very temporary fitting. There is other valves which can fit on there, obviously a gate valve or a ball valve, and if that was to be, there's no reason that we wouldn't use that as the fitting and the isolation method during the hot tapping. But generally speaking, if that was to be done, it would be done because that valve would remain on there as a permanent feature. So this is a 24-inch hot tap which occurred in Mexico, and as you can see, the fitting has been put on the pipeline as we showed before, and this is not a sandwich valve, this is a full operational ball valve. And the reason that's there like that is after the tap has been done, that valve will be an integral part of the pipeline, and it will remain there. That is not our property, it is the pipeline operator's property. The big difference being, if you think of a drill, if you think of that sandwich valve, which was quite thin, the drill has to pass through that sandwich valve before it starts drilling the pipe. Similarly, it has to pass through this whole valve here before it gets to the pipe. You can't see it on this picture, but what it means is that the tapping machine is extremely long because of that, because it has to have a lot of travel to get onto the pipe before the drill occurs. These are the cutters we talk about, and as I say, cutter itself is no different to what you would buy in B&Q, although it's a bit more extensive and a bit more rigid. And that is the cutter is the size of the hole that you want in the pipeline. But every one of them will have this pilot drill. And the reason that allows does allow it to go in exactly the position you want. It also has a secondary or a very important function, and I'll come on that a little bit later. And these are this is a cutter. I don't know what diameter that is, but it's big. That's the back of an articulated truck. So movement of this equipment when it's on the big jobs is very logistically challenging, and it's something that takes a lot of planning and a lot of project management.
Regarding this cutter, do you have 3 millimeters?
3 millimeter?
Yeah, cutters, real cutters also.
3 millimeters?
Yeah.
No, the smallest one we do is 1/2 inch, so that would be 12.7. But a 12.7 will just be a drill. It won't be a cutter. I think it's about 2 inch you start moving from a drill to a cutter. Primarily because you can't have a drill which is this diameter. You're really limited to the diameter of the drill, and that's when you transition to the cutter itself. Okay. So by if you think of drilling a hole, all you're left with is the hole and a lot of swarf. And that's quite easy to disperse and get rid of. If you drill a hole with a cutter, what you're left with is a piece of metal. And the worst thing that can happen in a hot tap operation is that piece of metal falls into the pipe. Because if it's in the pipe, it's difficult to get out.
So the other one was a drill, yeah? The other machines you showed before?
No, the drilling machine itself is the machine. This is basically the drill that you would fit into the machine and cut the pipe.
The other one, the T something you mentioned?
Right. So basically, this could be the T101 or the T906, whatever, and this is the cutter head, what we call the cutter head, and then the cutter holder. That is the cutter there. So that is the cutter. But each cutter will still have a pilot drill. So this machine can cut different diameter holes in the pipeline. And what you would do is you would change the cutter diameter. So that cutter diameter might be 6-inch diameter, but you could also put an 8-inch diameter one on there as well. But every one of them will still have this pilot drill because you need to start the hole off in the right position.
What I'm saying, because the thing is, like, if you want to steal, for example, from the pipeline, how are you going to drill the hot tub? Will you only drill machine, or you need to also pipe it?
Yeah, so it will follow.
Yeah.
Well, if you do illegal taps, it doesn't really matter. But illegal taps do occur, and believe me, they don't go to this extent. They just drill a hole, and if you think of the first slide I showed where there was water everywhere, well, illegal taps is like that, but it's oil everywhere. But I guess there'll not be a question in the exam on illegal taps, will there?
I want to buy some of this drill machine.
Start business.
Right, so the drill itself and the cutter, well, the one thing that will happen is you'll be left with a piece of pipe, or a portion of the pipe, and you have to make sure that that can come out. So the pilot drill we talk about has another function, has what's called U-wires on there. So as that drill passes into the pipe, the U-wires actually fall down, and they actually prevent the piece, the coupon as it's called, from falling into the pipeline, and we can actually pull that out. And there you can see the U-wires there, just on the edge, and this is the piece of pipe which has been removed. So we've actually drilled that hole for that diameter, and then we've actually withdrawn that out of the pipeline. So that pipeline would have been left now with a hole to that diameter in there. But more importantly, there will be no piece of pipe lying in the pipe which would restrict any pigging operation, for instance. Again, this is showing just now the recovery of the coupon. From an integrity point of view, this is an important piece of pipe because this is giving the operator information on the inside of his pipe which he wouldn't necessarily have. He will always have data from ILI runs and things like this, but this is actual visual that he can take. So they do always take this away and carry out investigations on it. And it gives them a little bit of information on the integrity of the line.
So, excuse me, sir, when you cut out these things, this coupon, what about the chips? How do you manage them? Or they just go through with the
shape? The sheath which will go is it's just this drill size here. So you're only putting that amount of, a very small hole in there. So the swarf which will come away with it will fall into the pipeline. That can be swept out with a pigging operation. And you will see that once you do a pigging operation. If you have had a hot tap operation on there, you will pull out bits of swarf. So getting back to your point of illegal tapping, that is something that pigging operators will look for in certain areas of the world. If they start to see swarf in there, it will give an indication that somebody's been doing something on the pipeline they shouldn't have. Again, this is just some examples of the coupon which is coming out. You can actually see the profile of the pipe itself, so that obviously the actual pipeline is something like that.
Excuse me, how to avoid spark when you are cutting it?
I'll come on to that because everything is self-contained and it's purged before you do it. So if you think of the early slide of the drill, it's not like that. Everything is contained in a pressurized system or a pressure containing system which will be purged with nitrogen. So there's no, even if a spark did occur, there's no oxygen in there. Because the only thing you have is nitrogen and the product itself. And this is where I show you there. So basically what you've got is, this is the fitting which has been put on the pipeline. This is the drill machine which is bolted onto the fitting by now. This is the sandwich valve we talk about. And as I say, this area here is purged with nitrogen. So once the drill goes in, and if there was a spark occur, and this could be hydrocarbons in here, it will not affect it because there's no combustible catalyst in there. It's an inert environment.
So it should be properly sealed there actually when you...
Yes, it is all. It is the fitting. The fitting which is welded on is the first process. It is then assembled. The machine is assembled. It's tested. It's pressure tested. It's purged before you start the drilling process.
So you put this your machine on the pipe here, and you purge it.
Yes.
You vent it.
Yeah.
And then you will start the drilling.
It's all sealed. Then you start the drilling. And obviously, once you drill through this pipe, there's a release of pressure into here. And that will then fill with product, whether it be hydrocarbon or whatever, but it will be contained. It won't go anywhere because this is all pressure tested such that once the pressure is released, it will not go anywhere.
Will you not equalize your housing with line pressure first?
You can do that, and I'll show you how you do that a little bit later.
Excuse me, please. Sorry.
It's okay?
How do you cut this coupon and it's so smooth like that? Is the cutter pushing it down?
Yes, the cutter is pushing down. So if you meant the small ones are pushed down by hand and they're screwed down, the larger ones it's a hydraulic motor and a hydraulic ram which actually takes it down. So it's a big machine. It's a big, it's a sort of factory produced machine.
So when it pushes the coupon down, it doesn't affect the other sides of the pipe, the wall and maybe the shape or something?
No, it's quite a clean cut. So it's and the big question that you have is that you have to make sure that once you start cutting here, that cutter does not come through the bottom. So it's quite there's a lot of calculations go on before you start cutting into the pipe. So again, considerations you've got when you do a hot tap. Pipeline material is the first one. You have to ensure that the pipeline material is acceptable for hot tapping. Pipeline wall thickness, you have to make sure that then the pipeline wall thickness comes more into it. If you're going to start welding on fittings, you have to ensure that it is thick enough to accept a welded fitting, and that will influence your welded fitting as well. Obviously, the pipeline geometry and integrity, it has to have a certain roundness, because the fitting will have to go around it and it will have to fit onto the pipeline. And obviously the integrity of the pipeline, you have to know that it isn't such a severely corroded pipeline that you may actually cause problems if you start welding onto it. You need to know what the product is and the flow rate. There is a limit, and it will vary pipeline diameter, but there is a limit as to how much flow you can have when you drill into a pipe. And obviously pressure as well. We mentioned the limitations on pressure because there is a lot of pipelines which are higher pressure than that. And again, temperature comes into it. And also, this is more for the purchase of the fitting itself. You've got to know what the applicable pipeline codes are for that pipeline, and they can vary around the world. There's a lot of a company like TDW produce the fittings you see there, and in an ideal world, we produce an exact fitting for every country and every company in the world. Unfortunately, it's not like that. Unfortunately for us, it's not like that, because there are so many different variables of onshore codes, and a lot of the big pipeline operators have their own codes. So for instance, Shell has their own codes. So we produce a fitting for Shell. It will have a slight variation to a fitting we might produce for another operator. Saudi Aramco is very unique. They have a huge storage facility of fittings, but all of them fittings are to a Saudi Aramco code. They're not to anybody else's code in the world. Slight variation. If you put them all side by side, you wouldn't know the difference, but the way they've been made, the preparation, the welding procedures that they have to be followed with are specific to them. And again, equipment choice, we talk about the different machines you would use. You have to have the right machine for the right job. And all that means is there's a lot of engineering preparation that goes into each project. At the end of this, I'll show you an animation of an actual project, so you'll get a feel for what actually goes on an operation. So what you want to avoid when you go into a hot tap operation, a misaligned T, for instance. If you're planning to put an off-take or a pipe coming off at 12 o'clock, if you weld that T on with the off-take at 3 o'clock, your pipeline is going to come off at 3 o'clock. You cannot do anything about it at that point. So you have to get it in the right position. You talk about how does the cutter work. The cutter has to be right for the job. So cutter failure is obviously can be a catastrophic event. We have to avoid that at all costs if we can. And obviously what we're trying to do at all times here is avoid a pressure release. So we have to make sure that whatever happens once we drill into that pipe, it's contained. It's not going anywhere other than inside the housing of the machine. You have to make sure we talk when we talk about stroke here, it's actually the travel of the drill itself. And you saw some of the examples there. If you have to travel through a large valve, you have to make sure that you've got enough stroke to get through the valve and through the pipeline. So we have to pre-calculate all that before we do it. We also have to make sure that we don't have too much stroke. So the worst thing that there's only one thing worse than having one hole in a pipeline, is that's having two holes in a pipeline with a hole in the bottom. It's just not, it's not recoverable once you do that. You will actually release, there's no means of containing the pressure. So that is one of the key things when we do a hot tap operation, or any hot tap operation, is that you do not go through the bottom of the pipe. The other one, as mentioned, is if we don't get that coupon out, that is a huge challenge to get the coupon out of the pipeline, especially if it's a size on size. So if you've got a 24-inch coupon lying in a 24-inch pipe, it is very difficult to get out without actually cutting into the pipe again. And then obviously, after all this process is done and the hot tap company walks away, we have to ensure the worst thing, another bad thing that can happen is we have a leak on completion. It has to be able to contain it after we walk away. As I said, the fitting remains on the pipeline. It's an integral part of the pipeline. It's there for the life of the pipeline. So this is all of that in place. This is just like a sequence of slides which will show you how it goes on. So we've already said we've put the T on. This will all be NDT'd, so we know it's fit for purpose. We've assembled everything here. So this is the tapping machine. So this is the stroke that it's going to have. This is the cutter. This is the pilot drill, and this is the valve that we would use to temporarily isolate it. So the first thing is we would bring the machine to the point of contact with the pipe. So that's, this is free travel. Nothing's happening at this stage. It's the drill is coming down through the void in the whole assembly. And then what will happen is we will cut through. So at that point, you're breaking through the pipe. So this is the point of no return. You've now got a hole in the pipeline. Okay? So yeah, you kind of go back at this point. And then the pilot drill will continue through and the cutter will come into place. So you're now at the stage you're going to start cutting the exact hole diameter that you intended to cut in the pipeline in the first place. And that cutter will go through. And again, as we say there, cut through by calculated measurement, because we don't want it to go much further than this, through this point, because that actually takes you through to the full cutting diameter.
So you are sitting on a computer, yeah? All the measurements?
I'd like to say it's all done by computer, but believe it or not, all of this work is done by hand calculation, and there's a form which goes out with the job, and somebody writes in.
As he must know when you should stop.
He's got to be able to work a calculator. Wow. So I will come on to some work we do offshore where we've got out of that, and it's something that we do want to take onto the onshore. But that's just for interest at the end of the slides. We talked about this U wire coming in, and that's literally all it is. It's shaped like a U, and as it goes into the pipeline, it's sitting in like a U like that. And as it gets through, as the pilot drill goes through, it drops like that. And when it drops like that, that means that it will catch the coupon, so the coupon cannot fall into the well. So it's a really significant part of the process, but it's probably the most simplistic, and it's something that there's no reason to change because it does work. Typically you'll have more than one U wire just to be sure in case one snapped or something like that, but generally speaking it sits on the first one and we pull the coupon out. And this is just showing the U wire here. So going into the pipeline, it sits neat, and then when it comes through the pipeline, it drops down. And basically what that means is it makes the pilot drill outer diameter go bigger than the hole it's actually drilled, so it can't come back out. It's a bit like a barb, if you think of barb on a hook, fishing hook. Once it goes in and it can't come out.
Might it be that the internal flow will not allow to fall down that one?
That's why we have a number of them, and there are different orientations. So at some point it will fall down. Gravity will eventually bring it down. Okay, but yeah, that's why we have more than one, just in case. So, yeah. So again, it's retained by the coupon wire, and then as we retract the cutter and the drill, the coupon will come with it. Okay, so we've now recovered the coupon, we've recovered the cutter. It's actually out of the pipeline, but it's not past the valve itself. But once you take it past the valve, you can close the valve then. So you can actually stop operation then, and the pipeline is pressure's contained. You've got a valve which is working, it's containing it, and you would vent off the product here, because this is still pressurized product. So you would vent it off, you would purge it again, and then you can take that off. And that, in theory, that is your hot tap done. But most of the time, the reason you do a hot tap is because you want to do something else with it. And I'll come on to that in a minute. So every coupon which comes out is marked up, it's taken away, and engineers will have a look at that, and they'll gather a little bit of information. Might not tell them anything. I mean, in an ideal world, there'll be no marks on the inside. It will still have the coating, and that will give them an indication that the integrity of the pipeline is still good. But they will match it up with ILI data.
Excuse me, can you go back, please?
Yeah.
How to be sure that there is no space between parent metal and fitting? How to be sure that it's
Parent metal and fitting.
Fitting, yeah, between them, that there is,
because that's
isolated.
That's welded at the initial stage.
But it's welded ends.
Yeah.
How about
And it's also welded along here as well. There's a weld, because this is a shell, so there will be a weld which runs along here and fully around the circumference, and then it is tested. It is radiographed, or it's
between this place?
I can go back to the, just bear with me, I'll go back and I'll show you the fitting. So there's the fitting which goes on. The fitting initially is in two parts. So the top part sits on the top of the pipeline, the bottom part sits on the bottom. That is then a weld which will bring the two together and seal them.
No, I understand this one. Can I show you?
Yeah.
I cannot explain. No, I understand that this is welded as well. I mean here, inside of this part, that it's isolated.
It doesn't have to be. It doesn't have to be. There can be a void in here. It doesn't matter. It doesn't have to be a neat fit. It's not the sealing element of the fitting.
So the product can go there.
Yes. Yeah. The sealing element of the fitting is this weld.
Yeah.
Well, these two welds and this weld here. What goes on inside is not too critical. It can be lived with. Okay.
Excuse me, then is it possible for gas pipeline only liquid?
Yeah, you can do liquid. So it will be very small. Whatever's in there will be very small and will not affect the integrity. There's no means, there will be no flow. If it does fill, it will never change. It will remain for the duration.
Excuse me. Compared to manufactured fittings, how good are these fittings?
How are they manufactured?
Yeah, compared to the manufactured fittings, so one that was designed before construction. How good are these fittings compared to those ones?
So a fitting which is going to be put into the line at the beginning, they're almost identical. The idea of a hot tap fitting is to replicate an initial installed design fitting. That's the attempt of it. Obviously, it's slightly different because it's been welded on the outside of the pipe rather than being part of the pipe. But generally speaking, it's exactly the same. It follows the same codes and the same specification.
After the hot tapping, you said the last stage of the hot tapping, we need to bend and we need to forge.
Yes. So basically, you have to vent off here. So that's the light blue colour there is the product, whether it be oil, whether it be gas, or even high pressure water used. You still need.
The subsea operation, do we some nitrogen cylinder down to there and then.
Well, but you've sealed the operation. You've sealed the pipe, the operation here. So you've sealed the fitting here with the valve. So this is still product, and that's product. This is being vented off, and then you would purge it. So then you've recovered, and when and these days tend to avoid venting off. It's captured somewhere, and then it's purged, and then it's inert at that point, so you can take it off.
What I mean is for the subsea operation, for the offshore operation, for the offshore, how can we purge?
On a subsea, you just run a hose down. You would. It's obviously this is more covering the hot tapping, but I have included a slide at the end which actually shows a subsea hot tap operation, and I'll show you it. It follows exactly this principle. The only difference is that where you have a very short pipe here, you will have a very long hose which will go to the surface. So they'll actually take it to the surface, and they will do it on a vessel. Yeah.
That means, do we have some water depth limitation?
The limitation of water depth is primarily by how far a diver can go down, which is generally considered as 200 meters now, but there is still areas where people can dive to 300 meters.
So you need hyperbaric.
Completely different game when you get offshore. Generally speaking, it's not a welded fitting. It's a very complex mechanical fitting. Okay, so.
There is a question regarding this erosion process for the flow. Is it has some effect for the erosion if you do the hot tapping?
There's a lot of talk about what effect putting a tapping into a pipeline does from an erosion point of view, and does it influence the integrity process or corrosion process as we go on. It still gets done, and it still gets talked about. It's, I guess there will be situations where erosion can come into play, but generally speaking, this is still considered an acceptable means of putting an offtake or a requirement into a pipeline. Okay. Once you've got a hole in a pipeline, there's generally speaking, there's got to be a reason you've drilled that hole in a pipeline. For all of the reasons you're talking about, what you're bringing to the whole process. One of them reasons is that you would put a stopple in there, so you're actually isolating the pipeline for a period of time whilst you do something else. So stopples, which are all they are is plugs which go in there and contain the pressure. I've said they'll come in pipe diameters. I've said 4-inch and up to large. We haven't really got a limitation on stopples, but we wouldn't like to say what the maximum one is. But generally speaking, you can do 56-inch stopple without. It just means it's a very heavy machine. Pressure ratings, again, we can go to 102 bar. There's no reason why you can't stopple at 102 bar. And again, the temperatures are a lot lower than what you can do with hot tapping. The reason that is because the stopple is a rubber-based compound, and obviously that will be temperature dependent. So depending on what you use, you can get up to about 82 degrees. So the stopple machine looks in principle similar to the hot tap machine, and that is because it will have to fit on the same sandwich valve that you've left on the pipeline. So one process follows another. So generally speaking, you will have the stroke, which is requiring to push down the stopple. This is the stopple here and the stopple head. So this is the sealing element. And basically, instead of drilling a hole, you've already got the hole, you're just pushing this into the pipeline, and it will actually turn in the pipeline and form a seal in there. There's an animation which shows that. So all of the elements that you've had previously, the fitting is already there, the sandwich valve which is already there, and then the stopple machine, which is similar to the tapping machine, and the only variance is instead of a cutter, you've got a stopple there, or a plug. So sequence of events, not a lot of difference to what we saw with the drilling operation or the cutting operation. You'd reopen that valve, which would introduce pressure here. You can actually use a bypass here, and it shows that a little bit later. But for simplified version, the stopple will drop down into the pipe. At this point it is not in the correct orientation for plugging, but as it moves down it will deliberately turn on itself 90 degrees, and then it will at some point seal the pipeline. So the sealing element is this black portion here, and that is now sealing the pipeline pressure. Pressure is coming in this direction, so it's the reason it does that is as the pressure there, it tries to pull the stopple equipment into the pipeline. That is, we consider, TDW anyway, consider that to be better than going the other way and having a thing trying to push out of the pipeline. So it's all about reactive forces. So this is the setup that you've got once you've done that. So you've fitted basically 4 T's on here. You've drilled 4 holes, and you've then applied 2 stopples. So this is your isolating here, and you've also put a bypass on here. So this is another temporary pipe work, and the reason that is the whole function of when a lot of times you do a hot tap and stopple operation is with this process it allows flow to continue. So you're not stopping pipeline flow. And generally speaking, in the pipeline industry or in the fluid transportation industry, whether it be liquids or gas, ultimately flow has to continue. To stop flow, there's got to be no other way to do it. And typically then when you get into the offshore side, that's what tends to happen. You have to stop the flow. But in the onshore market, there's more than one means of continuing flow, and a hot tap stopple bypass operation is one of them.
Well, I imagine there is you tend to drop the pressure in the line when you are taking.
Sometimes they do. Sometimes they don't have to. If the pressure is within the ranges of the stopple operation, then you don't have to stop the pressure. Similarly, if the flow is within the range, if the flow through the pipeline is within the range of the stopple operation, you do not have to stop the flow. So that is an ideal operation where the pressure and flow does not have to be altered for the operation to go ahead. Sometimes it does. If you've got higher pressure or high flow rates, you may have to drop them to do this operation. But it has to be reviewed on an individual case. Okay. 2 small fittings in the middle there. They are there to relieve the pressure in here once you've isolated it. So obviously you can't cut a pipeline under pressure. You have to take that pressure out before you cut it. And this just shows you. So basically you would depressurize that through vents. And again, these are relatively old slides, and the new process is that you have to, in certain areas of the world, certainly in the UK now, you have to capture that gas. You can't let it be released out. And then that you can cut that. The whole purpose of doing this is the pipeline operator wants to do something with this section of pipe, and he's now got the ability to do it, and he hasn't affected the flow. So his end user is happy. He's still getting gas or oil through there, and his contractor's happy because he's got a safe working place to work. These are just some of the big examples of plugging heads. So this is a stopple as it would sit in the pipeline. That is the pipeline diameter that it's going to seal on, and obviously this is the diameter that it would bolt onto. So that's just an example of some of the large sizes that you would use. And this is just a section through a pipe showing you as it drops into the pipeline. This is a wheeled arrangement here, so there's actually a wheel sits on the bottom and it actually forces it into that angle. So again, back to that picture I showed you at the beginning, hopefully it makes a little bit more sense now, in the sense that this is the pipeline that they want to do some work on. This is probably the valve they want to, or the offtake that they want to carry some work out on, certainly the work area. So what's happened here is this is 2 stopples. So there's been 2 fittings put on here. We've hot tapped through there and we've inserted stopples. So we've isolated this section. Some small fittings you see there, that's where we've released the pressure. And we've also put 2 extra fittings on either side of that. We've put a bypass around there. So that work site is ready to be worked on. So this area here will probably be depressurized now. So the contractor who has come in can work on that. Well, the end operator who's taking the gas, let's say it's a power station or something like that, is still getting gas because it's coming around the bypass instead of coming through the main pipeline. It's a very temporary fitting. Once the work is complete, all of this equipment is removed, but the fittings we talked about which go onto the pipeline, they will remain, and they will stay there for the duration of the pipeline life.
Excuse me, do the pressure need to be reduced in the bypass operation?
No. If the operating conditions of the pipeline allows that bypass to work at full pipeline pressure, then it will stay at full pipeline pressure. If it's too high, then it may well have to be reduced, and similarly the flow might have to be reduced. But generally, it should be able to operate as is.
Regarding the cutting operation, so normally, like in process plant, to do the cutting operation downstream of the pressurized pipeline, we need actually the double block.
Yes.
Do we consider this as a double block?
This one here is not double block, it's single block. Okay? And the reason it's single block is it's got one plugging head in there. Again, the times are changing and an expectation is that you have double block. So what you would have, there's two variances you can have on this, and I'll show you what they are. One is you can have two stopples, so you can have an extra fitting and two stopples fitting in there. Or you can have what's called a stopple train, which is a plugging head which has two sealing elements on it, and that will give you the double block requirement. So yes, you're right, most operations now require double block, and certainly in an offshore setup you would need double block.
Excuse me. The bypass pipe spool,
Yeah.
that is brought in by the tapping contractor?
Yes, it is. It's brought in, and it's a temporary, it's taken away by the contractor as well. So at the end of it, that will be removed and taken away with the machine. But again, it is designed to fit, its specific size. It is tested. It is for during the operation. It's an integral part of the pipeline. So it has to be to the same codes, same requirements.
Sorry, one question. Regarding the stopples, I think it's fixed with pin, yeah? The stopple.
Yeah.
It's fixed with pin, yeah? If I'm not wrong.
Yes, it's hinged, so it does actually bend into it.
Yeah. Is it? Have you ever had a problem with this pin?
I'm sure we have. That I can't. TDW do 7,000 hot taps per year, and we started doing it in 1950. I think 51 or 52 was the first one. So I'm not going to stand here and say there's never been a problem, because I'm sure there has. I'm sure there's been more than one problem, if the truth be known. But yeah, all of this is heavily engineered. People have spent a lot of time developing this, and if there has been problems, they've been engineered out. So something like that shouldn't happen, but I wouldn't like to stand here and say it's never happened. As I mentioned, once we've actually completed the work, the one thing which is left on the pipeline is the fitting itself. And what you have to do is you have to seal the hole. So that hole is sealed with what's called a locker ring, which is dropped in there, and it's dropped in by the hot tap machine, a similar machine to the tapping machine, and it's actually locked in place. And that allows you to actually remove the machine, and you will not have then remove the sandwich valve. And then, just to make it safe, you'll actually put a blind flange on the top of there as well. So that is a tested piece of equipment, and that will form the sealing basis for it. I'll just run this. This is an actual tapping operation where you can see, and it's self-explanatory, and hopefully you can see. But please ask questions as I go along. So this is summarising what we've just talked about. So this is carrying out an operation on a pipeline. So this is the welded fitting going on. Okay, and we're going to do that 4 times. And then we fit 4 sandwich valves on top. And this is the tapping machine that's been brought in with the cutter. And that's happening in all 4 positions, so this is going to happen 4 times. This is the equalising pipe where we talk about, so that you can see it on there. And then we seal it off. So we've got a hole in the pipeline and we've sealed it off. And we're going to put a bypass around there at that stage. So the bypass is already in place before you plug it. And at this stage the product will not go through the bypass because it will always go through the point of least resistance, which is typically the pipeline. But to increase that resistance, you put a plug in it. And that stops the flow, and that will naturally induce the flow to go around the bypass. So at that stage we've now isolated. We need to release the gas. As I say, this is now captured in and we remove the section that we want to remove and put the new section in. So we carry out all the testing on that, we make sure we're happy with it, and then we repressurize up and we remove the stopple arrangements. And at this stage the pipeline is flowing in its normal state. And again, we'd isolate our section with the sandwich valves. And this is where the plugging, the small plug that goes in, and so the locker ring there, so that locks it in place, so there's no pressure can come past that fitting now. And what that allows you to do is remove the sandwich valve and all of the fittings associated with it. So you would carry out exactly the same process on all 4 fittings, and then you'd remove the sandwich valve, and you'd put a blind flange on top of there. So, sorry, that's jump, but that's what you're left with at the end of the operation.
How you're installing relief valves?
When you say a relief valve, it isn't. It just, generally speaking, it is not a relief valve on there. This is just a.
I mean, in order to depressurize the section that you're going to cut.
You have to put a similar small tapping in there. So sorry, didn't show that up. But basically, these are large hot tap fittings. You can actually put a small fitting on here, which is not full circumferential.
The same mechanism.
And then it's the same, similar, exactly the same setup. You would drill a small hole, small valve, and then you would release when you wanted to.
Is it welded? Is this little fitting welded?
It is, but it might not necessarily be full circumferential around there. It might just be a fitting on top of the pipeline.
In the animation, the video, the pipe that was replaced was kind of
It's just showing that it could be a river crossing. I mean, that showed a very short section. Generally speaking, I've got a long animation which is actually of a river crossing, and you can see what really goes, what is a true hot tap and stopple operation on that and why it's done. But I'll show that at the end of this. That's okay. Urgent for time.
What's the longest or larger bypass operation you can perform?
The longest. It's limited by the number by how much bypass pipe you could put in there. Generally speaking, they're not that long because there's not a requirement to do it. If you're going to be doing that, you would do it as 2 separate operations. And the river crossing I show is effectively 2 bypasses, one on either side of the river, rather than bypass the full river. You wouldn't do that. Okay. So double block and bleed, which is something you brought up. That basically, what does that mean? It means 2 valves, 2 points of isolation, both which can withhold the full pipeline pressure. It can also mean a valve and a stopple, so we can put a single stopple in, but if we can use an existing valve, then you have double block because of that. Or you could have a stopple and an isolation plug, so it's some other type of plug, an inline plug. Or you could have what's called a tandem stopple, so that's 2 stopples next to each other with 2 fittings, 2 machines. Or you can have what's called a stopple train, which is 1 fitting, and instead of having just one plugging head, it has 2 plugging heads on there. And basically that is done in 1 operation, so it saves the need for an additional fitting. This is an animation of what it looks like. So this is a tandem stopple, so there's 2 stopples in the line, This is a stopple train, so it's one entry and it has 2 stopple heads. The advantage of it is you only have one fitting, one setup, and one machine brought to site as well for each drilled hole. The reason you have double block is if your first isolation leaks, then this is what's called the zero energy zone. If pressure gets into there, it will be relieved through a bleed point, and that bleed point goes to a safe area, probably a tank of some description. Okay, so at no time should this second seal come into play, but in reality, if it did, it can still hold the full line pressure. So for that to fail, you would have to have this seal to fail, you would have to have your bleed point to fail, and you'd have to have your primary seal to fail as well.
So you like drill again for the bleed valve, yeah?
Yes, all of these have small holes, small hot taps in there. So yeah, you've got to remember that when an operation like this goes on, there is a number of tappings going in at all time. You'll also see that there's a reinforcement clamp on there as well, and that often has to happen because the hoop stresses that will be induced on the pipeline by a sealing plug are quite high, and you need to ensure that you can support them here. I've got an animation of this. This is what's called, it was a big project in Cameroon that was done about 2014 to 2015, I think. It was for a river crossing. So basically they were going to replace a pipeline which was crossing a river, and what the client said was that the Lompanga pipeline project is I forget where it is, from Central Africa feeding down to the west coast of Africa, and under no circumstances could flow stop. It's the lifeline of a number of countries and a number of operators. So the project was spent about 4 years in planning. Logistically, to get it to site was a big challenge, and obviously there was this whole series of stopple arrangements put in there and bypass arrangements to enable them to put a new river crossing in. But keep that in mind, it just shows you the number of fittings that were put on the pipeline. But there's a really nice animation of the whole process at the end of it. It'll take about 10 minutes. I'd like to get it in before we finish. Sure we will. So this is some examples of the site work that was going on. Volume of equipment which went in, there was 14 40-foot containers of equipment had to be taken into Cameroon to do this. So it was actually 2013 it started. The animation you see is over in about 10 minutes, 15 minutes, and it actually covers the full duration of this project, which started in December 2013 and finished in April 2014. So you'll see how squeezed up the animation does. But just to give you an indication of the location of where it was the logistics of getting everything to there, the weather at this time of year there was so critical, the timing when it's done. Really big project, one of the bigger projects in the world that goes on. As I mentioned earlier, everything we talked about on hot tapping was shown in an onshore pipeline. And there's no reason whatsoever that we can't do that offshore, and we do it offshore. TDW do offshore hot tapping. The big difference is it was the process we showed on the onshore. Everything was assembled at site. So we put the fitting on, we put the sandwich valve on, we bring the tapping machine in. You haven't got that luxury 200 meters under the sea. You've got to do the assembly on the vessel. So that's the tapping machine, that's the sandwich valve or the valve that we'll use, and the fitting we talk about is say hyperbaric welding can go on. Generally speaking, it doesn't. It's just so expensive. So it's a mechanical fitting which has a mechanical seal in there and a mechanical gripping element. So that is a highly complex piece of kit. There's not many companies in the world produce them, but it's a unique piece of kit. We talk about 7,000 TDW doing 7,000 hot taps a year onshore. There's about 15 hot taps per year go on offshore.
15?
1-5. in comparison. So that's the different magnitude of the type of business from offshore to onshore. But it goes on. These guys are not TDW. We do not have divers. So what has to happen is we employ a dive company, very specialised people, and they will train to do the hot tap for us. And they will feed information back to the surface, and will be TDW technicians on the vessel doing that. And they will actually pass that information through. So all of the problems associated with onshore applies to offshore, probably worse. If it's 200 metres under the seabed, you can't, or 200 metres under the sea, the surface of the sea. If something goes wrong, it's limitations. I did actually want to introduce one slide into here, and I apologise that I didn't, but if I do this again, I will. We've just completed a job in offshore Louisiana in the US, and these guys were doing exactly this, and the diver has to produce a log of every minute of the day as it goes on, so every time something happens. And they had to stop the job because there was a 12-foot manta ray just invaded the site. And we've got a great picture of the divers with a 12-foot manta ray above them. And we had to stop the job for 3 days because we couldn't do anything about it. As I mentioned, divers, pipelines offshore, there's a lot of them. Pipeline water depths offshore range dramatically. The North Sea here, the UK sector tends to be less than about 80 metres, I believe. Norwegian sector goes down to 300 metres. Beyond 200 metres, you can't put a diver down. There's a lot of pipelines in a lot deeper water. The South Stream project going in at the moment in the Black Sea is 2,500 metres deep, way beyond any diver going down there, so you have to do it remote. So the hot tap machine you see here doesn't have a diver working it. It goes down a similar assembly to what you saw, but it's operated by an ROV and it's operated by a computer on a vessel. So all of the manual calculations we talk about onshore, offshore, we've managed to do it that it's all done by a computer. And in an ideal world, we'd like to take this onshore, but I still think we're a few years before we do that. So this is where we'd like to go with it. We've only done a couple of these. Still a long way to go, but still development work to see. But this is the next generation of hot tapping, if you like. Other type of isolation that you can do, and this is more on an offshore environment, is this is called a smart plug. It's a TDW tool. And basically this is inserted into a pipeline like a pig. It's pigged into position, and then through communication through the pipe wall, you will isolate these two plug modules. So we talk about double block isolation. This gives you double block isolation, and the reason we do that is it leaves no fittings. The fittings on a pipeline is still it's a contentious issue with operators. So, in an ideal world they'd like you to take the fitting away, but you can't do that. Smart plug gives you the opportunity to do. You can't do this offshore. You're not allowed to leave fittings on pipelines. So that's why in most cases you don't tend to see hot tapping going on. So smart plug gives you the opportunity to isolate without leaving a fitting, and you can actually cut the pipeline either side. So this is all of the stuff that you saw with the stopple. This was done offshore this is offshore Malaysia, and this was done using two smart plugs. And that's actually the pipe cut, and it was raised to the surface there, and then there was a new flange welded on, and a new spool piece was put in there.
Sorry, for this one, how do you track this one?
It has a tracking system on here, and it's this can be tracked to within 1 inch on the pipeline. So we can get a really good location on this. It uses an electromagnetic signal. And we can see it from outside the pipeline. Okay, so that's introduction to what hot tapping and stopple, so intervention on pipelines. As I said, we've got time for it. I've got this video of the Lompanga project in Cameroon. I'll try and talk through it as it goes on, just to let you know what's going on, but as I say, it compresses. It's actually only 7 minutes long, so it compresses 6 month work into 7 minutes, so bear with us if I try and keep up with the animation, because it's a bit fast. So it was a hot tap and tie-in project in 2013. So basically what I was trying to do is, this is the pipeline, and they needed to replace this river section. I can't remember why it was, probably damage due to flow, corrosion, something like that, but what they needed to do. So the first part is they're going to put the new pipeline section in place, and they'll do all of the work associated with that. And it's occurring on both sides of the river, so there's almost duplicate effort going on both sides of the river.
So this is bypass, yeah?
This is the new section going in. So what they're going to do is they're going to lay this pipeline in parallel to the one that's already there, and they will weld it in place. They will clean it. They'll hydro test it. So basically, by the time they tie it in, they know that pipeline is in perfect condition for going in. So there's no testing requirements to be done once the tie-in occurs. Okay, so this is just flooding of the line, and they'll do a hydro test on it. And all during this time, the existing pipeline is carrying on operation. There's been nothing done on the existing pipeline yet. So that's the existing pipeline still operating here, and this is the new section that's going to go in. So they're just dewatering it now. They've hydro tested it.
Do you have an idea what the width of the river is?
The width, I don't, but I'm guessing Central African River is probably going to be quite wide. Okay, so what they've already done there, they've buried the pipeline. They're happy that that pipeline is good to go once they get the product in there. So this is now the hot tap and stopple operation. So this is going into the old pipeline, either side. So say basically same activities are going on one side to the other, and they're putting 3 hot taps in either side, so you can put double stopple, so a double block isolation and a bypass in there. So everything that we showed before they're doing here. So they're still flowing at the minute, but they've created a bypass ability here, and they're going to stopple it at this point. So the bypass is now filling. And they've isolated now, and they're making a cut on the pipeline. This is just a temporary pit trap which has been put in here, and all this is to do is displace the oil which is going to be left in the old pipeline. So everything will be tidied up afterwards and cleaned up. So at this time, again, because of the bypass, we haven't lost any production. All oil is still continuing to flow, and so the end operator's happy, the client's happy, and the contractors can continue working in this area. And what they're doing now is they're tying in the new pipeline to the old pipeline. Okay. So this is now going to become the new pipeline. So this is the old pipeline which currently is still operating. But at this stage they're ready to start commissioning the new pipeline and diverting the oil through it. So this pipeline is now taking over the oil flow. So that is the new pipeline now, full of oil and commissioned and ready to go. As I say, you've got to bear this in mind. This is 7 minutes, and this is 6 months' work occurring in 7 minutes here. So it doesn't happen that quick. and that is the new line taking over. So that pig which was dividing the oil from the water, that will carry on to the final receive end and they'll return it then. So what that's left them with is the bypass pipe work and all of the fitting arrangements, but also it's left them with a pipeline full of oil, which, you know, you can't leave a pipeline full of oil. You've got to get that oil out before you abandon it. So they will pick that oil out. So that's water being pushed in here, and it will displace all the oil back into the pipeline. So this was obviously done when oil was over $100 a barrel, because they didn't want to waste a drop. So they push it all back into the pipeline. So there's no oil being wasted, everything's recovered. And I'm sure if you ask the oil company this, they will tell you it was for environmental reasons, but I think it was probably because it was $100 a barrel. Okay, so they've now removed the bypass. You've now got a pipeline which is decommissioned. It's oil free, so it can be either recovered or it can be left, whatever the process is. And they will start backfilling and returning the land to its original condition. What will be left there is the fittings that were put on at the initial process. So all the fittings that were brought to site, they are on the pipeline. They'll still be there now, but they are an integral part of the pipeline, and it may have to be at the level of keep the integrity level of the pipeline at its original. So that was it. So hopefully that gives you, that's a real life project. It's a very big project, but it gives you an indication of what hot tap and stopple is. Okay, so any questions?
With a bypass with a large volume, would you have to control the filling rate of that to avoid slugging in the main pipeline?
Yes, you would have to. You've got to on something like this one, you have to ensure that that it's filled in a controlled manner such that you don't get pockets of air getting in the pipeline, things like that. And then obviously as the transfer over, you have to ensure there's a smooth transfer over. So a lot of calculations would have been done prior going into that to ensure that the correct diameters were put in and that the switchover process would be smooth and not affect the throughput through the line.
The origin of the name, hot tap, how is it? Why did you say that?
Well, it originates because tapping is a drill. So if you drill into a pipe, it can be considered tapping. The reason it's hot, if you do any work in a pressurized area, if you're working under pressure, you tend to have a hot work permit. So it's based on that. It's recognizing the fact that you're going to be drilling into a pressurized system. Okay.
You mentioned about offshore. Yes, offshore is you said that it's mechanical sealing.
Generally speaking, it's a mechanical clamp. Yes.
Mechanical clamp. So it's like different.
It has two sealing elements in there, and it's actually squeezed onto the pipe. And then there's what's called tension bolts which come in, and they will actually increase the tension, and also you can get what's called gripping elements, so they prevent the clamp moving as well. And they're called what's called structure clamps.
So it's a special thing.
Very special. It's very different to an onshore operation, but does the same thing. It encapsulates where the drill would go, and it seals it.
I have two questions. One, is it possible? Have you had projects where you take off like at 3 o'clock position, and then secondly, if we don't have to leave the valves in offshore operations, why don't we employ the same for onshore, so that we don't have to leave the valves on the pipeline?
First question, yes, we can do a 3 o'clock. There's no reason why we can't do a hot tap at 3 o'clock. Okay, so.
The second one is.
Well, the valves. Yeah. If a valve is to go in and be a permanent feature, then it will be a class-rated valve for the pipeline, and it will, generally speaking, probably these days, it's in an oil or a gas pipeline would be a ball valve.
Yeah.
But if it's a temporary valve, if that's going to be removed because maybe there may be an off-take being put in, or if it's for a stopple operation, that's why you use a sandwich valve, because it's very narrow and you're only putting it in there as a temporary fitting, so it's going to come off and then be taken away. But there's no reason you couldn't use a ball valve. It just means you've got a longer travel on the drill or a longer travel on the cutter, and it's a lot heavier as well. I mean, there's a lot.
You said the valves we use, I think the fittings.
Yeah.
Fittings, they are permanent fittings.
They're
We leave
permanent
them there
fittings. They have to be
after
left. Yeah.
the operation. But if there is a way we could carry out an operation and we
To remove
still
the fitting.
don't leave them
Yeah.
there.
Yeah. I mean that would be. I mean, certainly in Canada, they would love you to be able to do that. But unfortunately, the way it is and the design of it, you will always be left with a fitting on the line.
But you say in offshore we don't leave them there.
In offshore, what you don't do, well, generally speaking, offshore pipeline codes do not allow you to leave a fitting on a pipeline, which is why you don't get so many hot taps done offshore. But sometimes there is no other alternative and you have to leave a fitting, or you have to put a fitting in place and then look at a means of getting it off the pipeline at a later date.
So it's a very expensive operation.
Yes, yes, in comparison it is extremely expensive. And just an example of that, there was a project done in the South China Sea last year, which was a subsea hot tap operation, which also required isolation plugs to remove the fittings. So exactly what we talked about there. So that was an additional, and that was one project, one subsea project, and the isolation portion was over $5 million. So it is then, and then you get into the vessels and all of the other work. It would have been an extremely expensive operation in comparison to an onshore project.
How much money it costs to invite your company, for example, to replace the pipe?
It totally depends. I mean, it can range. It can range for, if you're a very small pipeline.
Yes,
if you're doing one hot tap on an 8-inch pipeline will be $25,000. Then it can go up to $5 million. It can go up to whatever. Depends what you're doing.
And the duration for that 8
Yeah,
inch?
yeah.
How long?
Just a few days. I mean, it's the fitting is done in one day, and the hot tap is done in a very short period of time. Yeah.
Is it possible to use for H2S machine to contain?
Yes, you can, but you've got to be very careful with H2S. More so on the sealing elements. So you would use the material of the sealing elements would be maybe HNBR, which is resistant to H2S, and obviously the components of the drill and the tapping machine as well has to be H2S proofed. You have to be very careful when you do H2S pipelines, but you can do it.
So when we have our H2S operation, is there any the duration limitation to put the stopper in place?
Not necessarily, because the equipment has to be NACE compliant when it goes in. So we have to. We can't just use a standard equipment on H2S lines. And it's not something. It's something that we wouldn't actively go out and look for work in H2S pipelines, but if it needs to be done, it can be done. Okay. Well, thank you very much, everyone. Hope it was useful.
Gary, that was excellent. Thank you very much. And I'm sure now, following that lecture, you're all going to get top marks on that exam question. Thank you very much. I'll see you next week.
So the exam question is from this, or are we going to get additional content?
The additional content's on Blackboard, don't worry.
Thank you.
That was excellent, Gary. Thank you. You really, it's so different the way you deliver to what I did.
No, it's just it's enjoyable. It's good.
And it's the fact that you know so much. I mean, you can tell you obviously got them very interested to the level of questions.
I was starting to look at me once, I'm because I wanted to get the animation at the end, because I think it's quite a.
It's good. It really.
It just explains what it is.
Yeah, it's just on the top.
Yeah, no, but I use this
Oh,
for me.
sorry.
Jay, where have you been?
Yeah, I've got this. It's a great picture when we did. I wanted it, just didn't get time to put it in, but I will if I do.
You'll have to do it next time. Well, hopefully you will agree to do it next time.
Yeah, yeah, no, that's fine. Yeah.
So you're away next week?
Yes.
When are you going away?
I'm actually going away on Friday morning, so but yeah, that's fine. Yeah. I'm glad I got it done. I was just when it came up and it cost, you know, and
For some reason they brought all electric cars this year, because normally my sessions are sort of marching in quick and they brought it forward.
Yeah.
But, anyway, I'm so pleased that you did this, so thank you very much.
no, it was enjoyable.
I thought that maybe yesterday during the lecture, maybe for the PE, I thought that there was a big tapping campaign. I don't remember what it was for the shell. So they have a picture problem and they solved it by tapping. Was it done by your company?
It may well have been. You know.
So that the stock was during 24 months. After 24 months, they did hot tapping.
Right.
Thank you very much.
Do you know where it was?
In Northfield, in Shell platform, Shell operated platform.
It may well have been us. Yeah. We have done a number of ones for sure. We do quite a bit of work for them.
You did take it?
But yeah, if they're hot tapping to recover pigs, then they've obviously had a problem. It's not standard practice.
Yeah, well, basically, just in case you are trying to, will this be a method you could use when you are doing the tie back? Maybe adding an additional tie back into your line or your network?
Yeah, I mean that's what it's done for. Is that you would so you would if you need to do a crossover or something like that, you can actually just use the hot tap arrangement to do it. And the one showed with the permanent valve will have been a crossover into something or tying into another line. So, thank you.
Thank you very much.
Thank you. Thank you.
Did you come back hard?
Yeah, I just broke.
Where are you parked?
I'm across in the civic centre, and
Oh, right.
I wasn't sure what it was going to be like.
No, in fact, what I should do is remember.
Relax.